Rome wasn't built in a day, guys. And so is Bitcoin. This was one thing that was really hard for me when I joined crypto.
Yeah.
It's like, I was like, dude, this is so stupid. What do you mean Bitcoin is worth $20,000? That is so stupid. The dude in 2011, he bought 2 pizzas for 10,000 Bitcoin.
I have seen that. Yes, sir.
He bought 2 pizzas for 10,000 Bitcoins. And people in 2020 asked him, do you regret it? He's like, no way. Why would I regret it? So this is a huge problem with blockchain, and we call it the Blockchain Trilemma. So the trilemma is between decentralization, security, and scalability.
I love the way we built BPC in general.
BPC is a good network.
If anything in this world is filled with heavy and fancy terms apart from investment banking, it's Web3. NFTs, DAOs, MemeCoins, and so many more.
And coming from a traditional Web2 background, it was so hard for us to wrap our head around these decentralized terms.
So for this season finale of Breaking Prod Season 1, we sat down with Arun, a blockchain developer at Fungify, to help us take a deep dive into these concepts.
He helped us understand Web3 concepts using first principles, and we ended up creating our own blockchain network.
Theoretically. This is Arun on Breaking Prod Season 1.
Okay. 3, 2, 1. Breaking Prod Season 1. We have Workle Tree with us. Or is it Workle Try? What do you
It's
call it?
Workle Try.
It's Workle Try.
Yeah.
Oh, is it something in, is it a concept?
Yeah, it's a concept in, it's a data structure actually.
Oh shit.
It's a very new data structure.
Oh, is it that same try which we have?
It's, you know Merkle trees?
Yeah, correct.
Yeah, Workle tries are very similar to Merkle trees.
Okay.
Yeah.
Very confusing terms though.
Yeah.
So, I mean, when we saw your Twitter profile, we saw like you keep changing names there. And like the recent one, when we called out was Workle Try.
Yeah.
And then you had a mask on. So, I mean, is there something which like people in Web3 generally do? Put their masks on for anonymity or something?
Yeah, people in Web3 usually like their privacy. You know, they like the anonymity because that's what Web3 allows you to be anonymous, to speak your mind. Because if somebody knows who you are, then people judge you not for your thoughts, but for who you are. But if you're anonymous, the only thing they can judge you for is your thoughts.
That's a powerful thought. Yeah. That's something which I agree with. Although like I've seen like a lot of people just use like NFTs or something. Where did you get this from?
Oh, this was a gift.
You have interesting friends, I feel. Would you want to keep it on, or would you want
That's
to
fine.
We have the Workle Try with us.
Yeah.
Hello, guys.
Hi, Arun. Now we can call you Arun, I think.
Yeah.
Yeah.
Now it's Arun.
Now Workle Try is gone. We have Arun with us. So you're telling about the concept. So is it something? What is it used for?
So Workle Try is a very new concept in blockchains, at least. So you know how in a Merkle tree, it's very similar to Merkle trees, but instead it's much shorter. It's easy to prove a lot of things in a Workle tree. So there's going to be a new update in Ethereum, which will change Merkle tree to Workle tree. Okay. That will make the network very efficient.
So it all went off my head. That's for sure. So today, when I was doing some reading on this episode, I literally was getting like an anxiety before the exam. Right, you are going to something which you have not studied for.
We don't know anything like.
Yeah.
Bro.
So today, like let's talk about things where, in a way that we don't know nothing about Web3.
Okay.
Right, we don't know anything. What goes on? What we know is like Bitcoin is too expensive, and
meme coins just go up and down.
Correct.
That's it.
And a common notion is you can earn a shit ton of money in Web3. So
And lose as well.
And lose as well, correct. So today we'll talk about mostly in a sense that we don't know nothing about Web3, and whatever you concepts explain, let's try to dumb it down too much.
Got it?
If you dumb it down too much, it will come to our level.
Okay, so the first thing I want to talk about is Bitcoin.
Okay.
Let's go to the start.
Yeah.
So why Bitcoin? What is the philosophy behind Bitcoin?
Yeah, correct.
Because if you remember back in 2007, 2008, there was a financial recession.
Correct.
Why was that? You must have seen the Big Short movie.
Yeah.
Yeah.
Because banks fucked up.
Yeah.
So you can't trust your money with banks because when they fuck up, then you lose all your money. So how can you own all your money? You have to keep cash. But cash is not, you can't use internet transfer using cash. So that was one of the biggest motivation for Bitcoin is how can you make a peer-to-peer currency that is completely online and everything is self-custodial. You don't have to rely on a bank. Everything is decentralized. So this was the primary motive of Bitcoin. And another big motive is that, you know how countries just print money?
Yeah.
Yeah.
So you have inflation. There are some countries where you have hyperinflation. If you look at Argentina right now, the inflation rate for this year is 237%.
Fuck.
So if you saved 1 lakh rupees
Okay.
this year,
Yeah.
the next year it's worth what? 25,000.
That is like evaporating your money.
Yeah,
Exactly.
literally.
So another thing that Bitcoin came up with is a fixed supply.
Okay.
The total amount of Bitcoin will never cross 21 million.
Okay.
Okay.
You can't make more than 21 million Bitcoin.
That's how they maintain the value of it. Like
Yeah.
somewhere around the line, because
So
it's a limited supply.
Exactly. There's a limited supply of it. So there won't be an inflation. So this was the core concept of Bitcoin. And after that, so many new cryptocurrencies came. Again, Bitcoin has its own set of flaws. And this is like the first set of blockchains. There's Bitcoin, there's Litecoin, there's Bitcoin Cash and all these. And then a new set of blockchains came around. Those are the Ethereums of the world. So in Bitcoin network, the only thing you can do is send money. Like send Bitcoin, transfer Bitcoin. That is all you can do.
Okay.
Ethereum came around and thought, okay, why are we only using a decentralized network to send money? Why can't we have arbitrary computation?
Okay.
Okay.
So that made a new revolution called decentralized finance.
Okay. What is an arbitrary
So, for example, I can have any arbitrary code. Let's say I own an NFT. Let's say I can create a deed for my land and I can put it on blockchain.
Okay.
And I can, if I want to send you that deed, I can send that deed to you. And you can have other tokens in the same network.
Okay. So basically, you're saying like any physical assets can also like just
Yeah.
turn into code and then can be shared across
Yep.
in a decentralized manner. So it will be more of an application than just sending money. Like
Yeah.
that's
And moreover, by arbitrary code, you could have things like lending platforms where
correct.
you could have where you can say, okay, I'm going to lend some money to you,
Yeah.
and in 20 days I get it back with 10% interest.
And
Yeah.
lending is where you make money.
Yeah.
Like the whole world works on lending.
Yep.
Literally.
So that's why this is called a decentralized finance. So blockchains like Ethereum, Solana, these are all something called a smart contract blockchain,
okay.
where you could run arbitrary code and you could execute transactions, and these lead way to a decentralized finance where you don't have to trust banks. So that's the core idea behind blockchain.
I mean, what we see online is something in like very tits and bits. We never know like exactly what's going on in Web3. And my intro to Web3 was around in 2020, I think. I had a few friends back, I think in 2015 or something. They were like meddling with some Bitcoin or something. And that time, like no one wanted to go into that maybe space, or very few people were there in that space. And those guys printed some good amount of money.
Yeah.
Eventually, I don't know where they got the tip from, or where they understood like these concepts from, or like how to even invest. I did not even know the concept of investing like in 2014, 15. Like you can invest money in like that, and those guys were like actually putting it in Bitcoin. I think Bitcoin was also very cheap at that point of time, or like
2014, 2015, it was still expensive. It was still I think around like $40. I think 2014, 15 it was like $40 per
still
Bitcoin.
cheaper than
Yes, cheaper.
what it is right
Way
now.
cheaper, bro.
Yeah.
Way cheaper.
So I mean, in that sense, like when it got hyped up in 2020 and 2021, I think a lot of would be like because of like investors putting in a lot of money in it, and there's a lot of marketing and hype around it. Do you feel that bubble is still there in Web3?
Like literally the bubble. Sorry to cut you off. What bubble we mean something like we know that there was a bubble of .com, right? Everyone thought that if there is a .com, you can make a business out
Yeah.
of it. Now everyone thinks if you are on blockchain, you can make a business out of it. Do you think that bubble is there?
So in blockchain, there's something called the 4-year cycle.
Okay.
Okay.
Every 4 years, the price of Bitcoin and all cryptocurrencies will go way up, and a year later it'll crash down.
Okay.
But if you look at the cycle, Bitcoin, for example, in 2013-14, it was like $40, $50, and then it went down to $20, and then it again went up to $2,000. Sorry, it went up, $2,000, and then it went down to something around like $1,000, and then it went to $20,000, and then $6,000. So, and with crypto, you always have this 4-year cycle where there is some hype, and then the bubble bursts, and then it goes down, and then it goes up again. But every time it goes down, it's always higher than its previous all-time high.
bubble. Yes.
So
it's like a graph which
Yeah,
goes up,
just-
but also like crashes,
it's
like
a-
steep crashes.
it's a jagged graph,
Yeah.
but it keeps going up. It's always trending up.
Local maxima, local minima.
Yeah, correct.
Those sort of concept
Yep.
comes in there. Makes sense.
Are we around that crash cycle?
Yeah.
So I can buy more
No,
Bitcoin?
this is where it'll start going up again.
Oh, okay.
Is
so
it a tip?
is it at an all-time low at this point?
No, now it's back to close to its all-time high,
Okay.
but it'll go up. It'll still go up.
Makes
So
sense.
right now, governments, for example, in the US, you can have a Bitcoin ETF,
Okay.
an exchange traded fund.
Okay.
So where pension funds, all these people, and 401k in the US, all these funds can invest in Bitcoin now.
But do you think like this, all these like you mentioned in the very beginning, right? That Web3 was created because like banks might fuck up because there's a volatile body which is there, but those things happen like once in a while kind of thing, if we say, right? However, the cost of running, I think Web3 or something might be like way too high because now like how are you getting returns out of it in general? Because banks would like have many financial instruments to give you returns out of things, right? So they can sustain that kind of money which is coming in and going out. Is it how does it happen in Web3? That how does money flow in Web3 in general?
So money flowing in Web3 is different for different projects, different blockchains. It's different for everything.
Yeah.
In Bitcoin, you have some. So Bitcoin works with something called a proof of work system, where you literally have to mine Bitcoin.
Okay.
So you have powerful computers running the Bitcoin software, and it needs to produce a block.
Okay.
So once you produce a valid block, then you get a reward,
Okay.
and this reward would be like X number of Bitcoins. Right now, it's I think 6.5 Bitcoins.
Okay.
So
Pretty good.
the people who run these nodes, they are the ones who are keeping this network alive.
Okay.
And for keeping this network alive, they are getting an incentive, which is 6.5 Bitcoin per block they produce.
Okay.
And it works a little different with Ethereum and Solana, where you have to, instead of doing something called a mining, this works on something called a proof of stake.
Okay.
So in a proof of stake network, you stake your amount, you stake a certain amount of Ethereum, and then you get returns on top of it, and then you validate transactions.
Is it like that's more like closer to a bank? How we do it?
This is still not closer to a bank because this is still a decentralized network.
I mean, but you're still investing like some amount of money which
Yeah.
you had,
Yeah.
and like that's your stake which you're putting in to like make that
to
network
make
alive.
the network to secure the network.
Correct.
Yeah.
What I'll try to do is try to take a step back here to just focus on one chain for now,
Okay.
and then we can draw parallels to it because if we talk about three chains, I think it's gonna become very complex
Yeah,
very soon.
For sure.
Got it.
Right. Which chain would you wanna pick at this point? Which one is the best one which you wanna talk about?
If you want to talk about the very fundamentals of it, then Bitcoin is a good chain.
Okay.
But if you want to talk about what are all the things that is possible with a network, then Ethereum is a good chain.
Let's try to do Bitcoin first, and then we'll come
Okay.
back to
Yeah.
I think
Yeah.
Ethereum because it's gonna get complicated for us also to understand.
Got it.
So when you're talking about Bitcoin, right? For anyone to understand how a Bitcoin would work or how these things would work, you're saying there's a first thing is a limited supply.
Yeah.
Right. That is like 21 million
Yeah.
total supply which is there. How do you like has 21 million coins been minted already? No.
No. So here's the thing. You know how I said whenever the miner makes a block, they get a reward. So this reward gets cut in half every 4 years.
Okay.
Okay, and it's an infinite geometric progression
Okay.
such that it just keeps reducing.
Okay.
So when you add everything together, the total is 21 million.
Oh, okay. Got
Yeah.
it. So the initial people who like started out, they might
They
have,
must have gotten like a lot of Bitcoin.
yeah, correct. Like they must be holding like the most amount of Bitcoins,
Yeah,
and then it keeps reducing.
it keeps
So
reducing.
much math in this, man.
Yeah,
Yeah.
literally,
So
it's
much.
math.
So much thought behind it. But in this particular context, right, in Bitcoin, so you're saying like 21 million will be the hard cap whenever it goes, and
Whenever it reaches.
definitely it's whenever it reaches. We never know. Well, I mean, we can calculate from the
It's
geometric
supposed to happen
progression.
in like 2149 or something.
Yeah.
The year 2149.
Okay. Keeping in mind that the people who are running those nodes alive are alive, right?
Yeah, they will be. I mean, like someone will run the nodes.
Yeah, correct. So Bitcoin only exists over those nodes, right? So people.
Yeah.
So for example, if we three start a crypto network tomorrow,
Yeah.
right? Then I'll have a system which
Yeah.
will have some information against which we are having a reward or a coin or something, right? That information has some value,
Yeah.
right? He'll have a system, you'll have a system.
Yeah.
For example, if total of us, we have like, we create our own breaking fraud coin.
Yeah.
And then we have like $10 or 100 rupees maybe, like at the best, you can mine. So how will it even start? Like, for example, in the fundamentals, how will it start?
So at first, let's say we are the only 3 people in this blockchain.
Correct.
Each of us are running our node. Okay, and the coin of our blockchain is the breaking fraud coin.
Okay.
Let's call it BPC.
Okay.
All right. So how it works is now blockchain is basically a ledger. It's just
Okay.
a Excel sheet. Just think of it
Okay.
as an Excel sheet. So first I have to make a transaction. So let's say I'm giving you 10 BPC.
Okay.
So I'll make a transaction. I'll sign it with my private key. So this is where all the cryptography stuff comes.
Correct.
I'll sign it with my private key and I send it to you and you, both of you guys.
Okay.
You both verify it. And what happens is you have to build a block.
Okay.
So building a block is where it gets a little complicated.
Correct.
In Bitcoin, how you build a block is you take a bunch of transactions and then you take the previous block's hash. And then you find a new hash and then you add like another number, something called a nonce. And then you keep changing the nonce such that the hash of the entire thing starts with 6 zeros.
Okay. So for example, if we are starting like you sent us 10 BPC
Yeah.
each,
Yeah.
right? Now there are 2 transactions.
Yeah. Now there are 2 transactions.
Correct. So now, for example, if we say, so a block is made up of some amount of
Number
transactions.
of
correct?
transactions. Yeah.
So for example, if we have like 3 transactions or 2 transactions per block,
Yeah.
for example, now we are eligible to create a block,
Yeah.
right? Because we have
There's a
2
yeah.
transactions in the ledger.
Yeah.
So that should create a block in general.
Yeah.
There's no previous hash.
Yeah. So that's something called a genesis block. So when we first make the network, we set a block called a genesis block and we give it a random hash.
Okay.
Like we give it a random hash for that.
So for
It's like
example,
a constructor function.
Yeah.
that's the
exactly.
origin
Yeah.
basically. So now, for example, if we call it maybe like ABC, that is like the unique ID for that particular
Yeah.
hash is a unique
Yeah.
ID, correct?
Yeah.
So we have a unique ID for that first Genesis block.
Yeah.
Now, how will that? So for example, now I can say that this is a block. For example, there's some complicated math through which I can consider this thing as a block.
Yeah.
From fundamentals or first principles, what I would go back to is I've created this block. Now, how will this block hold value in general?
So a block by itself doesn't hold any value. The
Okay.
block just holds data.
Okay.
So a block is just the latest state of the chain.
Correct.
So what will happen is when I give you the when I put a transaction out there, any of us can pick all these transactions.
Okay.
And we start constructing our block.
Okay.
Okay. So this is where the proof of work thing
Got
thing
it. So
comes.
basically, there was some ledger.
Yeah.
Now we never know which one is gonna create that block,
Yeah.
right? Someone, for example, Yashank starts to create a block for that.
Yeah.
He sees there are 2 transactions which he can like create a block,
Yeah.
that will take some computation power
Yeah, that'll take some computation
because
power
he has to create a unique hash.
Yeah, he has to find a number that, when hashed with these two transactions,
Okay,
creates a hash that starts with 6 zeros.
got it.
That's easier said than done.
Yeah, I understand.
Because if you think about it, it's very hard for him to create that hash, but it's easy for us to verify.
Correct.
It's hard to create, but easy to verify. So that's the whole point behind proof of work. And once he adds these two transactions to the blockchain, so now whatever balance I had, let's say I had 50 BPC,
Okay.
I gave, we all started 50 BPC, and I gave you 10 and I gave you 10. Now in the public blockchain, my balance will go to 30, yours will go to 60, yours will go to 60.
Got it.
Okay, so whenever he solves that equation where like he has two transactions, he can uniquely identify those two transactions as a block.
Yeah.
Correct. That will be another unique ID basically for that block which will be created. Transactions had their own ID, whatever.
Yeah.
Right. And then there's another hash which you want to create, which will create a unique ID.
Yeah.
Right. So that is one block in my blockchain.
Yeah.
And that block will represent what? This whole transaction where you paid us something.
Yes.
It's like the proof that he
That's the
paid us
proof that I
and we
paid you.
received it.
Got it. Makes sense. Now we're building up to something.
Yeah.
And to build the next block, you use the current block's hash.
Okay.
And whatever new transactions are there, and you find some number that when all of it are hashed together, results in a hash that starts with 6 zeros.
Oh, okay. So we'll keep
So
doing
that's why
this.
it's a blockchain.
Oh,
because dependent on the previous block's hash.
Yeah. So I mean, we can, because creation is hard because it's gonna add some permutation combination of numbers, which is gonna result in such.
Yeah, you're
such
gonna
a
do
condition.
trial and error.
Yeah, it's gonna go trial and error. It's gonna just. So maybe if there are like n number of people now, for example, if apart from us three, there is another fourth person which comes in, and then they say that, okay, I see these transactions in the ledger, I can mine this as a block.
Yeah.
Right. Correct. So now they will earn the money, or will earn the money because you send
So
it to
whoever
us.
mines the block, so you'll get the money that I sent you.
Okay.
But there's something called miner rewards.
Okay.
So for every block that is being mined, our network will provide a small reward. Let's say 1 BPC.
Okay.
So if they successfully found a number that, when hashed together with our transactions, produces a hash with starting with 6 zeros, then they'll get that 1 BPC reward.
They'll get a new minted coin.
This is a new coin that will be minted.
This is not from our balance. It's from the chain itself.
Yeah, from thin
So
air.
basically,
From thin air,
that
correct.
person helped to compute the whole thing, and it saved my computing power. So as a reward to that person, he gets 1 BPC.
Correct.
So that's a reward for helping out there.
Correct.
Yeah.
So for example, now total coins are like 50 plus 50 plus 50 plus that one coin.
Plus that 10.
So 151 or 160.
Yeah,
whatever.
160.
Right, 10
Yeah.
he got. So 160 is the total coin limit.
Yeah.
Now the total coin limit may be like 10,000 coins or whatever, right? So this will keep increasing.
Yeah.
Right? And every 4 years, or maybe for us, every 4 hours.
Yeah.
Right?
We cut it in half.
Cut the coin. So 10 will become 5. So like within those 4 hours, whoever mines gets 10 BPC. After that, people get 5 BPC.
Yeah.
After that, they'll get 2.5.
Yep.
After that, 1.25.
Yep.
Something like that.
Now things make sense.
I wanted to do it from the first principles to
this
understand.
makes sense actually.
How is it even working? So now, we need to keep our computers alive, right?
Yeah.
We need to keep, like, for example, if one computer goes down, then what happens in general?
So here's where the distributed computing system, like the beauty that went inside Bitcoin and all the other cryptocurrencies come. So if one computer goes down, it doesn't. Let's say if there are like 20, 30 people, then if one computer goes down, it doesn't matter because somebody else will keep mining the blocks.
Correct. I mean, because now the ledger is between all of us.
Yeah.
Right?
Yeah.
So we all have a copy of it.
Exactly.
So
And
even if one goes down, at least one should be alive.
Yeah, and not at least, at least one should be alive. And here's the thing. So once you create a block, you send it to everybody in the network. So they verify it. Yeah.
Correct.
Did you do the block right? And once they verify it, you get your reward.
Makes sense. Because now verification is easy.
Yeah,
because there'll be
verification is
like
easy.
decoding is easy, encoding is hard.
Yeah,
right?
because you have to find a number that hashes to a certain thing. They just have to hash whatever number you gave them.
Yeah.
and check
Yeah.
the same thing. So I remember when the first time I talked about blockchain, so there was this free app from somewhere and I was trying to read about it. So the first thing they told was literally this, like, if you want to have a transaction, everyone needs to approve it. If you want to remove a transaction, everyone has to approve it. They never told the math behind it, basically, but now it makes sense. Why? Because they just told like everyone has a copy of it. If you want to remove a transaction, it has to be approved by someone. But if you want to add a transaction and verify it, everyone has to approve it. That's why they said like if you add it to banking system, everything, so there is no black money. So that everyone has a transaction that it went out there. So NGOs, if they work, they'll figure out that it actually the money went or not.
Correct.
Now it all makes sense how this the math behind it.
Because like let me give you an example from our BPC coin.
Okay.
Let's say we have 3 people here, and Vivek comes to us and he says he just made a fake block, say giving himself 100 BPC. He comes to us and says, guys, I have 100 BPC, but we both have the ledger. We can see in our records that he doesn't have it.
Yeah.
So we can invalidate his block. We can be like, no.
Do we get to punish him?
No.
Do I get kicked out of the blockchain? No.
No one get kicked out of the blockchain.
No, in Bitcoin, no, you don't get kicked out.
Okay.
In other
We'll
chain.
keep it here.
Yeah, okay.
So the thing is, there's no penalty for like creating a fake block.
Yeah.
Or I mean, fake block can be like I just say like some random ass hash,
Yeah.
and then I say like, okay,
It'll
this
just get
is also a
rejected.
valid block.
Yeah.
But you guys can verify it's not a
Yeah.
valid block, so it's gonna
It'll get rejected.
it's gonna get failed, right? Now, again, I'll come back to the same thing. How will this? So, for example, we have our own cute little world where we have a BPC, right?
Yeah.
We can pay each other in BPC. We can like maybe buy this glass of water for like 10 BPC or something,
Yeah.
right? You agree in its value, I agree in its value, he agrees in its value. How will this correlate with the real world? Maybe like if someone, fourth person sees it from outside, he's like, there's 3 fucking stupid people like trying to just play with coins. How am I gonna get a part of this? That is one. Or like, how will this add value to me, right? In
Like
general.
how and why?
So this was one thing that was really hard for me when I joined crypto.
Yeah.
It's like I was like, dude, this is so stupid. What do you mean Bitcoin is worth $20,000? That is so stupid. But then once I got into it, I realized value is a very human-made thing.
True.
Like even if you think of something like gold, gold is basically worthless. There are very few places that you use gold, like in electronic circuits and all of it. So functionally, gold should be cheaper than aluminum because aluminum is used in far more places.
Yeah,
it has more
correct.
functionality. But why is gold valuable?
Because I think one, a supply is limited, or like everyone agrees that this should be valuable.
Exactly. There's a social consensus.
Yeah.
So value is created by social consensus.
Makes sense.
So that's why you can see. So the value of anything is basically how much someone willing to pay for it.
Okay. Correct.
So that's the value of anything.
Correct.
So at start, Bitcoin was worth nothing.
Yeah, because like no one believes in it.
Yeah, nobody believes in it. Nobody knows it. But when you slowly started getting social consensus, everybody started believing, okay, there's something to it.
Okay.
And that's why you can see the price go up.
Okay. So for example, coming back to a BPC, right? So in BPC, the value is nothing at this point for any other person using a traditional currency, which is staked on gold.
Yeah.
Right. Most currencies, like for example, they like stake their price against the amount of gold.
correct.
Country
They have
has.
a Federal Reserve.
Yeah, Federal Reserve against they do it. So now, for example, for us, there's no Federal Reserve at this point, right?
Yeah.
I think that would be a good thing or not? A good thing for one. That's the doubt actually. So should we have like something which we
Staked around
stake
it.
it against, or not have it something staked against?
Okay. So let's look at somebody making vegetables.
Okay.
Okay. Let's say I have a farm and I have vegetables. And the price of the vegetable is pegged against a currency, let's say US dollar, Indian rupees, whatever it is. So in this case, again, I'm asking you the same question. Does it help that the vegetables I'm making is pegged to the currency?
I mean, if I'm also like having the same vegetables, I can like share with you, you can share with me, and like we can all be happy.
Yeah.
Right. So I think
Like the barter.
it's like a barter
Exactly.
thing. So right now we have a barter kind of system between.
So Bitcoin is a commodity.
Okay.
So the price being pegged to something, it doesn't matter.
Okay. In
Like
general,
it's-
like if I have like an apple, and you have an apple,
Yeah.
like both apples are for us in the same domain.
It's the same thing.
Yeah, it's the same thing for us. Like, there's nothing like
Yeah.
a better apple or a non-better apple,
Makes sense.
right? So now we have established that we have a coin. We have 3 people in a block. We have a miner who is mining for us.
Yeah.
Right. Maybe we are not mining for now. There's a miner who has a good computer who is mining. For
Let's
us.
say there's a set of miners
There's
because
a
it
set
needs
of
to be
miners now.
a bunch of people.
Correct. So now that person created a mine block. We verified it. That's all good. Now for the value again, if someone, now what I will do is probably if a lot of people are using it, then we all have like a social consensus that this is something which is valuable.
Yeah.
Now if someone wants to, from outside, wants to get into this chain, they would want to buy some, like we have to be selling also. We sell like, we put like, okay, I'm selling like 10 Bitcoins.
Yeah.
But, or I'm sorry, I'm selling 10 BPC.
Yep.
And those 10 BPC are worth $10.
Yeah.
Right? If someone wants to buy those 10 BPC, they pay me $10. I'll give them 10 BPC from my side. It's again going to go through the same thing.
Yep.
Right? That's how the value of a BPC would be created.
Yep.
But I have a doubt here.
Yeah.
So let's say if there is no transaction happening on our chain, okay? So will the miners get to know that there has been no transaction, so they don't have to mine, or they just keep mining and whenever it happens?
So to mine a block, they have to add a transaction inside it.
Okay, but do they get to know like transaction is happening?
Yeah.
Under that?
Yeah. Usually it has some. Usually all these blockchain have something called a mempool, a memory pool,
Okay.
where you have like a bunch of transactions,
Okay.
and miners can pick whatever transactions
Okay,
they
that
want.
makes sense.
Oh, okay. So it would make sense to now with this now since there's a mempool. Now for us there'll be a pool in which all these transactions are written. Basically for us it's an Excel sheet where all these transactions are written. Miners can come and just like pick up the transactions which happened recently in the last few rows, and then they can choose to create a hash for each 2 transactions, right?
Yeah.
We can club more of them as well, right? Instead of
so that depends on something called the block size.
Okay.
So Bitcoin has a 4 megabytes block size, I think. Yeah.
Okay.
Sorry, 1 megabyte. Yeah.
Okay.
So if we have a consensus between everybody who's running our BPC node and say, okay, instead of adding only 2 transactions per block, we'll add 20.
Okay.
If everybody agrees, then we can go ahead and do it. Even if not everybody, at least if the majority, the 51% of the people who run
Makes
the nodes
sense.
agree, then you can increase the number of transactions.
Correct. Okay. So do they write? So for example, I have like 2 lines of thought now here. One line of thought would be around for the people who are verifying it. How would they verify? Will they write a function for it, like a mathematical function? Through which
It's
they
very
verify?
simple. Let's say you send them a block saying, okay, this is the previous block hash, these are the transactions, and this is the number that I found, such that when you hash all of it together, it gives a
6
hash
zeros.
with 6 zeros.
Correct.
All he has to do is just take everything, hash it together, and see if it starts with 6 zeros.
And hashing function would be something.
Yeah, SHA-256.
Okay.
Yeah,
So
just
okay.
a general
That's a
hashing
standard
function.
thing.
Yeah,
That's a
standard
standard
hashing
thing.
function.
So we just like take all of these values together, or there'll be some unique hashes of each.
Transactions.
Yeah, there'll
Correct.
be hashes of the transactions.
These are basically string values.
Yeah.
We add those, concatenate those strings
concatenate
together,
all those.
and then again hash it together.
Yeah, and then you find a special number and then
correct.
you hash it.
Okay, because else like it's not
Yeah.
gonna come to 6 zeros in the
Yeah.
beginning. So we add that random number. So the game is to find that random number to have like the hash which will have 6 zeros in the beginning.
Yeah.
So now we have also established that we are having some verification system which people can hash together. Correct.
And people are willing to buy.
People are willing to buy
across,
also,
Yeah.
right? Because now there's some value.
there's
Because
some
now
value.
we are selling like maybe we are saying that we'll get this helmet for like maybe 20 BPC.
Yeah.
Right.
Makes sense.
So for this, if someone wants to buy this, now they have to get that coin itself,
Yeah.
right? In general, for getting that coin now, because they want this to get that coin, they need to pay me some money so that I can give them some coins.
Okay, so it's similar. Let's say we start tomorrow that we have some merch for Breaking Prod, and if you want to buy that, it's only possible with BPC.
BPC,
So now they have to enter it, and then only they'll be able to buy it. So
they
you won't be able
need to have BPC to buy that
Yeah.
in general, and that thing which they're like commodity, which against which they're buying it, that should be maybe valuable to them.
So that's the project behind that chain. Is that's the thing that is valuable to them, so that they have to enter to the chain to get that. So that's the project behind that. That's interesting.
Have you guys heard of this story? There was a dude in 2011. He bought 2 pizzas for 10,000 Bitcoin.
I have seen
What?
that. Yes, sir.
He bought 2 pizzas for 10,000 Bitcoins. And people in 2020 asked him, do you regret it? He's like, no way. Why would I regret it?
I mean,
because he used Bitcoin the way Satoshi Nakamoto intended, the founder of Bitcoin, as a peer-to-peer cash. So he's like, why would I rig that? I used it as a cash.
yeah,
And that was
correct.
a-
I mean,
He's the reason why we are here.
Exactly. That was the first time somebody used
Yes.
Bitcoin to buy something.
oh, okay. So now, because now we'll come back to this, but now I have a very interesting question. So now, since we have this BPC, right? We have a chain of 3 people, 3 nodes. We have transactions. We have blocks. People who are verifying the blocks, does everyone need to verify this block?
Yes.
So
Everybody
now-
needs to verify and update their own ledger.
So whosoever have the
Okay, so
nodes
they update
running.
their own ledger,
Yeah.
they verify and they update. What if they don't verify?
Then they get dropped off from the chain.
Okay,
Then
because
they have-
their ledger will be out of sync.
Yeah.
In general.
exactly.
And are they can we create a program which does this for us always?
Yeah, there are programs. There's Bitcoin software available, like something like a Bitcoin software that you can write that just does the whole thing.
Okay, makes sense.
And will they get an option to come back when they are ready for that?
Yeah, they have to. So using the peer-to-peer network, they have to download some of the latest blocks. They have
Okay.
to verify it all, and then they can join again.
Oh, okay.
Yeah, if you want to, let's say we are already running our BPC network, and somebody new has to join, they'll just get a bunch of blocks from us, like the last 20 blocks or something.
They also verify it.
Yeah, they'll
and
verify
they're-
it, and
they're
then
part
they'll
of it.
start they'll be in sync with our network,
Correct.
and they'll also start verifying all the new
Correct.
blocks.
So now this will bring us to the point that there are like some amount of, so all of these are just for sending money. That is
Yeah.
one. Second thing is now we'll land at a deadblock of, I feel, scalability in this sense. How will we tackle, like, how does now Bitcoin tackle it, then we can tackle it here? Or does it not even tackle it at all?
Because what I see is, as a Bitcoin, if I have a node running, I literally have to run so many validations every day because there is a transaction happening somewhere else and I need to validate that. So how that scale come
So-
into the picture?
So in traditional networks, the more servers you have, the more nodes you have, the more capacity you can do. Like for example, if Twitter has more nodes, more servers, then they can handle more throughput.
Correct.
But in blockchain, that's not the case.
Okay.
Even though you have 200 different nodes, your capacity is the capacity of one node.
Correct.
Okay.
That's it. Because every node has the same thing. Every node has to verify the same thing.
Okay. So they're not doing anything in parallel or something.
No.
So that, okay.
So this is a huge problem with blockchain, and we call it the blockchain trilemma. So the trilemma is between decentralization, security, and scalability.
Okay.
So different blockchain falls somewhere between all these things. They choose, like, they can't have all 3. They can only have 2, or you can have some of each, but you can't have everything perfectly. And different blockchain choose this differently. Like something like a Bitcoin is very decentralized, it's very secure, but its scalability is shit.
Okay.
It can do 6 transactions per second.
Okay.
In contrast, the Visa network, you know the Visa network, right? Does 10,000 transactions per second.
Okay. In like the traditional money.
Yeah.
Hmm.
So that does a 10,000 transactions per second. Bitcoin does 5, 6.
Okay. And the reason for that choking is what? Because
Security and the
Again, because security and decentralization. For example, you could have, let's say, instead of doing 5 transactions per second, let's say you have to do 500 transactions per second. Now it becomes very hard for other people to verify. So all these people can't afford to have their rig mine for Bitcoin, because again, it'll get a little harder for them as well. So they can't mine more Bitcoin. So a lot of the nodes will drop off. So if many nodes drop off, then you lose the decentralization.
correct.
So it becomes more and more centralized.
Oh, okay.
So
that's
eventually-
how, I mean,
So eventually it becomes to a point, it just reminds me of a political stuff where there are people who have different opinions. If you start dropping them, it happens in Indian politics where they were jailed or anything. They are not there to say. It eventually comes to the people who agree to that term.
Yeah.
So
Yeah.
if I want to do a scam, all the people I know, they are only in the node. The people who are against it, and they got dropped off because we are trying things very fast. Only people who are there to accept to me, they'll do that, and the transaction will get lost in between there.
that's
So
how
the
you
security will be hampered
Yes.
there, right?
Yeah.
That's why that's the dilemma right there. And that makes sense also. That's why it has to be wider enough, decentralized enough, so that it has the security connected
Again,
to it.
why decentralization is important is that, let's say you only have 10 nodes. Instead of 100, you only have 10 nodes. Now, these 10 people can censor your transactions. They can choose not to pick up your transaction and add it to the block.
Correct. I mean, I can very well do that. If I have a BPC and then like there are a number of people who just join BPC, I would just say, no, I want to just not take their transactions and I'll not bind their block even.
Yeah, and this goes like even big. For example, take Bitcoin for example. Let's say if Bitcoin becomes more and more centralized, then it'll be easy for countries to put sanctions on them and say, oh, you know what? You shouldn't accept transactions from China. You shouldn't accept any transactions from Russia. Then the foundation of Bitcoin is lost there.
Yeah.
Because Bitcoin is built for everybody. So
Being anonymous.
yeah, being anonymous, and it's built for everyone. Like you shouldn't be able to censor transactions.
Being anonymous is a philosophy of
Yeah.
Web3.
Being anonymous is a philosophy started by the founder of Bitcoin, Satoshi Nakamoto.
Okay.
Nobody knows who he is.
Okay, he's not a real person maybe?
He's people think it's Satoshi Nakamoto is a surname for a group of people,
Okay.
but nobody knows who they are. Nothing.
I mean, how do you publish a paper if like you don't have an identity? Don't they ask like a social
you
security?
just publish it on
Aadhaar
archive
card?
And make a $20,000
You just publish it on archive. Anybody's free to do
Okay.
so.
It's like a peer-reviewed
Yeah.
thing. Okay.
This is where he put the first Bitcoin white paper, Satoshi Nakamoto. And you know the greatest thing Satoshi Nakamoto did? His wallet has so much Bitcoin, and that wallet has never been touched.
What?
That wallet has billions of dollars worth of Bitcoin,
Okay.
and that wallet has never been touched.
So it has never done a transaction
Nope.
ever. So it's just preserving Bitcoin basically.
Yeah, it's just.
Is it
it's
preserving
just
a
there.
value? So
It's not. It's not even like he just chose to walk away.
okay.
Like I'm pretty sure he just deleted the private key of it or something of the wallet. But yeah,
I mean, if people agree, now coming back to BPC, for example, if Arun started BPC, right, or if we start BPC, for example, now Arun has like a shit ton of BPC mined with him, right? I'm not sure how we will mine more. We'll come back to that.
Validate more and
You
more.
have 50 basically at this point. How will you like earn more revenue? So that will come to it.
Yeah.
For example, now you have like maybe like around 5,000, like which is 50% of our limit, right? You have 5,000 BPC in your account. Everyone else who believes that Arun will not sell his stake, we are all technically staking against him,
Yes.
isn't it? I mean, if Satoshi Nakamoto starts selling all of his coins, for example,
that's basically like burnt supply. Like nobody, if you know that he's not going to sell it, then that's out of the market.
no, it's burn supply, but it's also like kind of making you believe why is someone holding it.
Yeah.
Right. That adds to the value system.
Yeah.
Like for example, like if tomorrow, for example, all the gold just evaporates.
Or people just say that gold is shit.
Gold is shit. Like or maybe I'll come back to the evaporation part because evaporation is like more close to this. Right, gold is shit is something we are saying like okay, BPC is nothing. Like I'll not accept this for a BPC. Right, that's a different. That's another way of losing the value.
Delusing
One way of losing value is that the physical thing is gone.
Yeah.
Right. There's like nothing. There's no gold tomorrow.
Yeah.
And now people can't like have that promise in a note anymore. So this. Wouldn't you say like Bitcoin has the Satoshi Nakamoto ka so much wallet? People know that there's some amount of coins there which can be used sometime, maybe like Achanak said.
Yeah, and so if it hasn't been used this long, then there's a good chance it's not going to be used.
I'm not sure about anything else, but I may become a fan of him after this. Like people listen to Taylor Swift and become Taylor Swifty, right? But no, this actually makes sense because this is just not like some random person coming and saying, "Oh, I'll just start my new currency." It has a thought behind. It has a mathematical reasoning behind, and how you'll prove everything.
We are building that.
Yeah, literally we built that right away because someone had that thought behind that.
There was some thought which we built upon right now. We were gonna continue this for a while. I think this will help us understand more of this stuff which is happening.
Another thing about Satoshi Nakamoto is, so at that point there was various different hash functions, and he did, and all of these were government approved, like to use in the government systems and everything.
Okay.
but he didn't use any of those, and he chose SHA-256.
Okay.
And later people found out all the hashing functions that was government approved, everything had backdoor.
Okay.
Oh.
Okay. I mean, they choked at some point.
Yeah. And he used this very new thing. I think SHA-256, the first major usage was in Bitcoin.
Wasn't like SHA-256 coming from SHA-128 anyways?
Yeah.
So that was like an older thing. Right?
Yeah. But there were other things like, not MD5, but there were a few other hash functions that were the industry standard back then. But he chose not to use any of those. But those had backdoors.
And now we like...
Now we know those had backdoors.
Yeah. I mean, now like SHA-256 is like the gold
real standard.
Yeah, gold standard of...
right now it's SHA-3. Yeah, I think right now
it's SHA-3.
Yeah, right now it's SHA-3.
Like most of the like Web2 places use SHA-256
Yeah.
for hashing.
Yeah, SHA-256 is good enough.
Most of
Yeah.
them.
I think it's not going to expire like for a...
Yeah. There hasn't been
amount
too
of
much
time.
collision in... so what we call collision is where you hash two different things and you get the same
Eventually
hash.
come out to
Yes.
the same.
Yeah, there are some hash functions like MD5,
Yeah.
which are like so many collisions are there. People have a list of different things that you can hash and you'll give the same things.
Correct.
So SHA-256 is still not there. So people still use it.
We mostly rely on social knowledge from Twitter or somewhere. So
Correct.
So those things are not coming to us. Is it something like that, or is it
So
a distraction?
again, here's the thing. Even if meme coins didn't exist, 90% of the people wouldn't care about the tech. It's just the way it is. People like money go up.
Yeah.
True. So I wouldn't say meme coins are taking the limelight away from all these tech. How I see it is meme coin bring people into the ecosystem and they slowly start learning about these things as well.
They're like a marketing thing.
Yeah, it's a huge marketing thing.
So like whatever marketing budget you would have,
Yeah.
you're putting it on a meme coin and starting a new meme coin.
Like the hype, that's the hype
Yeah,
around
that's
it.
the hype. Because like if you talk to a layperson who don't know any tech, let's say someone who's doing sales or some cashier, they don't care about cryptography. They don't
Yeah.
care about distributed systems.
Correct.
But if they see, oh, there's a funny coin that goes up, that
Yeah.
went up in value 10,000%,
Yeah.
they'll be like, oh wow, that's so nice.
But like then people would get like scammed and shit because like
Yeah.
if someone would create a meme coin and then they
Yeah.
would get
Rug pulls.
what would your rug pull be
A
like?
rug pull is where you go invest in a coin, and then the developer who made that coin, they just steal all your money and run away.
That has happened before,
That
right?
has happened so many times. That happens every day. Like you can take any 5-minute time frame and it's happening.
Okay.
But then how do you figure out that it can be a rug pull? Like there is a checklist that you should
Usually
go ahead
people
with?
have their own checklist. Like, okay, there are a few things that they check for. For example, how much of the supply of the token is with the developer, how long has it been, and each of these meme coins have their own community. So you can have, like go to Telegram and like talk to people, see how they are. If you like, then you can invest. For example, back in December, this is a funny thing. Back in December, I was scrolling through Twitter and I saw a dog with a funny hat, very much like this. I thought that was so funny. It's called Dog with a Hat.
Okay.
I thought it was so funny, and I immediately told my friend that this looks very funny. Let me just put $100 in it. If it goes to shit, it goes to shit. I put $100 in it, and now it's worth $10,000.
Fuck.
That's my. And in between, I actually took some money out. Even
Okay.
after that, it's like $10,000. If I didn't take that out, it would be worth like a good $30,000.
So the bottom line is you should find it funny.
You should
Yeah.
find it funny.
It's all about fun.
Are there any meme coins you're bullish on at this point?
Yeah, one is Dog with a Hat.
Okay,
and
that's
another one is
giving you 10K. So
Popcat.
okay,
Yeah, these are the two ones that I'm.
this is in 2024.
Yeah, this is in 2024. Both of these are on Solana.
And okay, so now since you talked about Solana, we'll come back to our BPC.
Yeah.
And we started out with Bitcoins, right? So which is a very simple transaction thing.
Yeah.
This episode is going to become like more, how do you have the thought process behind?
the Bitcoin 101.
It's not Bitcoin 101 even. It's like
Blockchain.
very blockchain 101. Like
Blockchain 101.
Like first principles blockchain. Like, this is more around that. Now, if you go back to having like an ETH philosophy, right?
Okay.
So in Ethereum, like you said, like you can have like arbitrary
Yeah.
computation and all that. How would that relate to a BPC?
Yeah, like let's say I like Ethereum now. I like the chain. I want to move from blockchain to there. So can I move the chain, and how does it
No,
work?
you can't
So-
move a chain.
You cannot
So-
move from Bitcoin to that.
Let's say
that's what I want to know.
let's say right now our BPC network, it only supports BPC transactions.
Okay.
So in the ledger, the only thing that you can have is that person A sent this much BPC to person B.
Okay.
That's all you could have.
That's all you can write.
Yeah. What Ethereum does is slightly different.
Okay.
So instead of having person A sent X BPC to person B, it's just bytes of data.
Okay.
Bytes of data that can be compiled in a virtual machine.
Okay.
Okay. So what this allows is that you can put arbitrary data, any data, instead of just saying, okay, someone gave someone BPC, you could have just random data like
I'll put
hello world.
Kendrick Lamar is not like us.
Yeah, yeah. You could like put the entire thing.
Okay.
And in Ethereum, you have something called an Ethereum virtual machine. So this data is usually a compiled version of a transaction. Like for example, again, if you take any action in a computer, it basically boils down to a bytecode, right?
Correct.
Like, let's say you're running a for loop. All that for a computer, that's just bytecode. So what you do is, instead of saying, okay, instead of putting a payment receipt on the ledger, you put this bytecode on the ledger.
Okay.
Okay. And now you run that, and everybody has something called a virtual machine. In our network, we introduce a new thing called a virtual machine.
Okay.
So you can run this bytecode in your virtual machine and you can update the result.
Okay.
Update the result of the ledger.
Yeah. So let's say now in our BPC network, we want something called we want a stable coin.
Okay.
We want Indian rupees to be represented in the in our
BPC network.
in our BPC network.
Okay.
Okay. So what we do is there's an entity. Let's say RBI comes to us and they say, okay, you know what? Instead of issuing new new currency notebooks, we are going to come and issue new notebooks inside your network.
Okay. We'll issue new BPC INR types.
Yeah.
It's a new type of coin.
Yeah, new
itself.
type of coin,
Yeah.
BPC INR.
Okay.
So what they do is they literally make a new database inside our own blockchain.
Okay.
They make a new database.
Blockchain is basically our systems.
Yeah, our system. Our blockchain is our shared BPC network.
Correct.
So blockchain itself is a database.
Okay.
So they come in and they make a new database inside our database. It's like a smaller database inside.
It's like a collection inside a database.
Yeah, exactly. You can think of as a hash map inside a database.
Correct.
Where they store for each person, they say, okay, he owns 100 BPC INR.
Okay.
Vivek owns 100 BPC INR. So, and then now if I have to give you 50 BPC INR, then I make a transaction and I give it to the subset there, which is the bytecode. I basically give the bytecode in the transaction, and that bytecode, when you execute, it'll update that, it'll take 50
Subset
BPC
of-
from me and give it to him.
And that subset will be updated.
Yeah, exactly.
Okay.
And the subset will be updated.
Holy shit. Okay. Now I understand where this is going.
Yep.
So this bytecode someone will be writing
Yeah,
and that will become a smart contract.
exactly.
Okay.
So we won. I told you like we went to ETH India and we won one of this. So I wasn't writing smart contract, but now I know what we made.
Yeah. So basically,
no idea
smart
what it was.
contract is a fundamentally it's a way of writing bytecode
Yeah.
which can perform a certain transaction within a chain.
Correct.
Yes.
Right? Certain kind
Certain
of
things.
transaction. Yeah.
Yeah.
Certain kind of it can do certain things. Correct.
Exactly.
Certain actions within a
Yep.
chain. Right. So for example, issuing an BPC INR is one action.
Yeah.
Transferring it is one. Delete we can't do.
Actually, you can delete.
Okay.
So in typically in blockchain, what happens is if you have to delete something, you have something called a dead address.
Okay.
So nobody knows the private key to the address. Nobody has access
Like
to the
Satoshi
address.
Nakamoto's address.
Yeah, something like that. Nobody knows the access to the address. you just send it to that.
It's like burnt
Okay.
money.
Yeah,
It's
So literally
so you
burning.
can burn the
So
money as well.
literally you are
So if you
burning
burn
that.
the cash which you have in hand in real life,
Exactly.
you can send it to a dead address on a
Yeah,
blockchain,
exactly.
right? So
That's smart.
That's smart. I mean, instead of that also burned. Like you cannot get it back now, anyways.
Yeah, you can't get
So-
it back because the person who has
Correct.
the private key should
So
send
the
it to you.
third
Nobody has
option our smart contract can do, our code can allow to do is to burn money.
Yeah,
Right.
burn money.
Literally burn it, like
Yeah.
they do in Fuzzy.
So when we create this VPC, we ourselves set up one dead.
No,
We have to do
you don't usually have to set up a dead wallet because there's a publicly used dead wallet.
Okay.
It's literally 0x0000 dead.
Oh,
That's the wallet address.
But we are creating the chain for the first time, so there's no wallet like that.
Yeah, but here's the thing: a wallet is not. So when you have to create a new wallet in a chain, it's nothing but like you don't have to register a new wallet. Nothing.
Okay.
You just have to say, "I'm sending money to this address,"
Okay.
and that address doesn't have
belong
to
to
exist before nothing.
Okay.
So, but if somebody has to access the address, they should know the private key
key
to
of
it.
that.
Okay. So, for example, now in BPC, what will happen is we had our own systems
Yeah.
where we had ledgers, and then we also have like a wallet along with it, or is it like the same thing?
So a wallet is basically just a private key and public key.
Okay.
So for example, let's say I'm saying I'm giving you 100 BPC. So you can also write the same thing. You can be like, okay, yeah, Arun is giving me 100 BPC, and you can add it to the blockchain. How can you verify that I'm the one who sent it? So you have something called a wallet. A wallet is nothing but a public key pair. So I have a public
Got it.
public key and a private key. So my
Makes
public
sense.
key will hold all my BPC,
Correct.
and I'll sign my transaction.
So that randomly anyone cannot. So it's
Exactly.
it's like a bank account and a UPI pin kind of
Yeah.
thing, right? So if you know that UPI pin, then you can say,
Then you
"Ki,
can
haan,
do
bhai,
it.
like I have that phone number and UPI pin combination."
Yes,
Right.
exactly.
Right? I have that phone number, I can register. Then I also know the UPI pin, I can transfer.
Yeah.
Right. Now, if I don't know either of those things, then it's not gonna work.
Exactly.
So for us, what will happen is we'll start having our own addresses with
Yeah.
public and private key, and then when we write something, we
You have
need
to
to have
sign
like
it.
both of those things.
Yeah, you usually just sign it with your private key,
Yeah,
and then your public key is known to.
known to everyone.
Yeah.
Right.
You just sign it with your private key, saying, "Yeah, from this public key,
Yeah,
from this
I
address,
agree
I'm sending
that
it.
I'm sending it.
I'm sending 100 BPC to person A, and you sign it with your
And-
private key.
Correct. So it's sent now.
Yeah.
For example, now if there's no one who's gonna access it, it's gone dead.
it's dead.
Yeah.
And if you have that private key for that address which I sent it to, then
Yeah.
you're gonna also able
then
to
I
get it
can
back.
then I can send it to other people.
But
Then I can use the address.
So let's say someday, hypothetically, that dead account, someone has that key
No.
to it.
Yeah.
He'll be the richest person on
You'll
this
be the
planet.
richest person. There's a lot of money in there.
So you can see how much is dead now. So how much is burned.
Yeah,
at
you can
this point.
see.
Okay.
There's
The
block
public-
explorers
yeah.
where you
Okay.
can see anybody's balance, where you can see all the new transactions
Okay.
coming.
So the whole thing is open source.
Everything is open.
So we talked about bytecode. We created a bytecode for doing certain items. What language will I write this bytecode in?
So-
Like Java compiles to bytecode. That's what I
Yeah.
know. What is the
So for
High-level language for
Ethereum, there's this language called Solidity,
okay?
and
Okay, that's where
Solidity,
Solidity comes
yes.
from.
yeah.
Okay.
And for Solana, you usually write it in Rust.
Why the fuck could they not do it in JavaScript? Or C++ or Java,
You can
for example.
actually in a lot of blockchain you can actually do it in C++.
Okay.
Because it actually compiles down in a few blockchain like Cosmos. The code compiles down to WebAssembly.
Okay.
That's a very standard opcodes, set of opcodes. So you can write it in C++. Why you can't write in JavaScript? Because JavaScript is not a compiled language.
So you need a compiled
Yeah,
version of a
you
bytecode.
need to compile it to something.
Okay. What are you working at this point?
So
Currently.
right now I'm working as a blockchain developer.
Mm-hmm.
I've been working as a blockchain developer for like 3.5 years now.
Mm.
And apart from that, on the side, I'm mostly working on cryptography and zero knowledge proofs.
What is this zero knowledge proof?
I'm glad you asked. So
It sounds very fancy though.
Yeah,
Like,
literally.
zero knowledge proof, like you don't need anything.
so zero knowledge proof is a new cryptographic primitive.
Okay.
It's very similar to.
Don't use any buzzwords like primitive.
Okay. It's a new cryptography thing.
Okay.
Very similar to encryption, decryption.
Mm-hmm.
But instead, what happens in a zero knowledge proof is I have to prove something to you without revealing what it is.
Okay.
Okay. And this is usually a proof of computation. For example, let's say you're colorblind. You have two balls in your hand. One is red, one is blue. You can't see the colors. You come to me and you say, dude, these are both the same balls. I say, no, it's not. So how can I prove to you that these are not the same balls without you having to believe me that it's red and blue? Like I can't give you the information that this one is red, this one is blue because you're colorblind. It
How
doesn't.
do you do that?
So how can you do it? So one simple thing I can ask to do is I can close my eyes. I can ask you to switch the balls in your hand. Okay, either switch or not switch. And then I close my eyes, you do your thing, and once I open my eyes, I can see if you have switched or not because I can see the colors.
Correct.
So the first time I do it, you'll be like, okay, you know what? This might be a fluke.
Yes.
Because there's a 50% chance I can guess. So I do it again. The more time we do it, the more confident you are that, okay, these two balls are different. Now I have proved to you that these two balls are different without revealing the colors.
dude,
Without revealing
holy
which
shit.
is blue, which is red.
Damn, that's very interesting to hear you on.
Yeah, this is a very
There
good
is-
concept.
There is like pulling a proof out of thin air, right?
Yeah.
Now you have the right amount of information, but not the exact thing.
Exactly. So this is huge with something. So where this comes in handy is that KYC.
Okay.
So you know how when you do KYC, you literally have to send them everything.
Yes.
Your Aadhaar card, your PAN card, your passbook, your bank statement. They have so much of your data. But with zero knowledge proof, you can say that you are a real eligible customer from India with let's say a credit score of 600. You can prove all this without revealing any of it, without revealing your personal information.
Makes sense.
Very interesting.
This is a very dope concept.
Bro.
I feel there will be my life before this podcast, after this podcast, specifically among this concept. Because for me, things always used to be these buzzwords. Never knew how things work.
Yeah.
I just knew that there is something that is running around. and people
I
are
want to
crazy
remove the
about it.
buzzwords, like literally.
Yeah.
With this,
The concept behind buzzword has to be there. When someone speaks something, I know what it is. It's just not the buzzword in my mind.
yeah.
And another thing with zero knowledge proof that's really interesting is that you can prove a lot of different things, and the proof would be very small. The proof would just be like a few bytes.
Okay. So it's like
size
size-wise it's small.
Yeah, the size is very small. Let's say I have to prove something really big. So even though I don't want it to, even though I'm fine with you knowing it, I have to send you a big thing.
Yeah.
Correct.
So instead, if I make a proof of it, that'll be very small.
Okay.
I can send you just the proof. And this is used, the zero knowledge proof is used in blockchain scaling.
Okay.
So again, I told you about the blockchain trilemma, right? Where you can't have all three.
Okay.
You can't have security, decentralization, and scalability. So what some blockchains have done is that they opted for security and decentralization. For example, Ethereum has completely opted for security and decentralization. It can do 13 transactions per second. That's
Ethereum.
it. Ethereum, yeah.
Okay.
Like 13, 15 transactions per second. That's it. So what people have done is that you have a base Ethereum layer and you have built blockchains on top of Ethereum. And they'll do a lot of computation. They'll have a lot of data and they'll just send to Ethereum a proof saying, we have computed all this right. And Ethereum will verify the proof. And if it's successful, it'll add it to its database.
Okay. So you solve for scale in this.
So offloaded the whole computation
Yeah.
from it.
Exactly.
And still be sure that this is
Yes.
true.
This is true.
Without knowing any of the data which is already
Yeah.
on the Ethereum chain.
Without
That's
knowing all
crazy implementation of things.
That's all just math, bro. All just
Bro.
math.
So, are you biased towards one of the chain?
Yes, I'm heavily biased.
Which one do you work?
Ethereum.
Okay.
So here's another thing. So Ethereum was founded on a principle called cypherpunk.
Okay.
So if you go and check it out, there's a cypherpunk manifesto. So this is a story time.
Okay.
Story time, guys. So back in 1994, 1995, encryption was seen as a weapon.
Okay.
So governments wanted to ban all encryption. So at that point, I forgot his name. The guy who invented pretty good privacy, PGP.
Okay.
Government, the NSA, the US government saw this as a threat, as a national weapon that other countries can use to harm the government or whatever. They didn't want normal people to have encryption. Have access to encryption.
Correct.
So they banned encryption. So what he did was he wrote the entire code and math for it on books, because writing in books is free speech.
Okay.
They didn't, so they don't think code is free speech, but writing in book is free speech, and he just gave it away to everybody.
Okay.
And he wrote a cypherpunk manifesto.
Okay.
So the core of cypherpunk manifesto is that humans are entitled to their privacy. So Ethereum derives a lot of its core foundational principles from the cypherpunk manifesto. Like, you should have your own privacy. You should be able to run your own node. Like, for example, if you have to send a transaction, you have to access it through a node. So it should be easy for people to run a node. You usually have node providers, like very similar to AWS. You have node providers that will run the node for you, and you can use their node to send or send transactions.
You just pay them.
Yeah, you don't even have to pay them, to be honest. Like, a lot of them are just public goods.
Okay.
Like, but the point is that you should be able to run it on your own. You should be so self-sufficient that you should not depend on anybody. You should be able to do it on your own. So that's why Ethereum has kept the node requirements so low forever.
That would require like them to have technologically that power to do that, because like else everyone would have done it anyways. Right, so you need something.
Interesting.
But when all of this is open source, how are people not copying their code anyways?
People copy all the code.
Okay.
Again, a value is perceived by human. Like, you can go and download Ethereum's code right now, and you can run your own Ethereum blockchain.
Okay, but again, there will be no value because
there'll be no value because people have to perceive value on it.
Have you ever found, like, because you said like this is so in crypto or in Web3, I think breaking prod makes more dangerous sense because now you cannot change that contract. Which you have done. Have you ever broke prod before?
No. not like the smart contract side of it, because usually before you launch your smart contract, you do like multiple audits, especially because this has something to do with money.
Correct.
So every protocol does like at least 3 to 4 audits, but even after that, hacks happen. And once hacks happen, it's impossible to get your money back.
Correct.
Because you don't know who did it. You can't like just revert the blockchain.
I mean, this happened with WazirX, right? A few days back.
With Wazir, it happened like a couple days back. Where they just stole the money.
And so, I read somewhere like the USDC is at 70 INR there. I wasn't sure how that can be possible because USDC has to be with USD, right? Or it can
be but again, each exchange has its own trading pool.
Okay.
So they can like, it depends on like demand and supply, right? So but someone can come and arbitrage.
I mean, this way you can like take money from one,
buy at cheap.
That's a huge thing in crypto. Arbitrage.
People do this.
Yeah,
actually.
People do this. Do you know Sam Bankman-Fried?
Correct.
In the start, how he made his money is by arbitrage. In Japan,
that was arbitrage.
Yeah, in Japan, Bitcoin used to trade at a slightly higher amount than in the US.
Okay.
So he used to buy Bitcoin in the US, sell it in Japan, pocket the difference.
Isn't that illegal?
No, it's not.
It's options, no?
Yeah.
Okay, so now, makes sense.
And even inside crypto, there's a lot of thing for arbitrage. Let's say you have 2 different exchanges. In one exchange, ETH is trading at, let's say, $3,000. And in another one, it's trading for $3,050. You can buy it here and sell it here.
If I don't have $3,000 then?
I'm glad you asked. This has some, because
I don't have $3,000, but I would want to do this.
Yeah.
So how would I do that?
So Aave is a protocol that came up with something called a flash loan.
Okay.
Where you can take a huge loan without placing any collateral.
What?
But you have to repay that loan in the same transaction.
In the same transaction.
So what you can do is, let's say in exchange A, ETH is 3,000. In exchange B, ETH is 3,050. You take $1 million loan, you buy ETH in exchange A, and then you sell ETH in exchange B for the higher profit, and you repay $1 million back. All of it happens in the same transaction.
Oh.
If any of the thing fails, the whole transaction fails.
So you don't have to pay anything.
You don't lose anything there.
You don't lose anything, but you pay a small fee.
Gas fee type.
And apart from gas fee, you borrowed $1 million, right?
Right.
Who's going to give you $1 million for nothing?
Uh-huh.
So you pay a small fee, let's say a 0.1% fee.
Okay.
You
Well,
pay
that's still
Yeah.
better than
Exactly.
like giving back and being debt of $1 million.
Yes.
It's still better working 14 hours a day and not earning
So this is
for that.
So yeah, you can't do that in traditional finance.
For sure.
This is something you can
Traditional
only
finance, my traditional finance mind cannot comprehend this fact at this point. What is a transaction then? Like now this
A
will
transaction
ask
is
me.
So a transaction can include multiple other transactions inside.
Multiple actions.
Multiple actions, yeah. Multiple actions inside it.
Oh.
So like
okay.
the signing
For
of the
example,
whole
if I
thing
do a
together.
checkout on a Web2 website, then adding to cart, checking out, paying money, and seeing the order details can be one transaction.
Yeah, all of it is one transaction.
So you write smart contracts to perform this.
Yes.
Because traditionally you cannot.
Yeah.
So you have to write a custom code.
You write some custom code saying,
These things will be considered as a one transaction.
Exactly.
Because it's anyways
Just
not
make one
writing
function.
A person paying to B.
Yeah.
It's a byte code which is
Yes.
gonna get on the chain. So that byte code could have all this information and that could still be called as one transaction.
Yeah, because
Yes.
transaction is similar, let's say in normal finance, if I have to pay someone, that person has to receive that, I have to pay that. Those two things is one transaction
Yes.
in total. Because there's two things happening, two actions, but it's the whole transaction.
It's the one
Same
correct.
happen for our APIs, we do transactions, right?
Correct.
Receiving and
Correct.
providing data,
Also,
all those
Abhi,
things.
for example, if you're sending USD to someone in US, then it's like a multi-step transaction.
Yeah, because it has to go to your bank first, from there to international SWIFT network.
Ah.
So there it's like multiple transactions.
Correct.
and then
That's
the whole
happening.
thing become one transaction.
Oh.
Yeah.
And if it fails, no one's like having anything apart from forex.
Yeah.
जो अगर हो गया तो
Correct.
कट जाएगा.
Yeah.
Yeah, some fees. Maybe here they're having some fees because we are taking a loan.
Yeah. And you pay like a
Oh,
0.1%
shit.
fee on it. See, this is not possible in traditional finance.
Correct. It's
And
not.
This makes for the efficient markets.
Correct.
Because you
correct.
want price to be very similar everywhere.
Yeah. Because when you like buy from somewhere, sell from somewhere, if you're doing intraday kind of thing, then it's
Yeah.
flickering at this
Yes.
point. And you're doing volume transactions, it's gonna make it unstable for you. I mean,
Yeah.
you can just lose money the next second. Some money, not like maybe huge ton of it, but crazy.
This is something that you can do on decentralized finance. When I first learned about it, even I was like, dude, how is this even possible?
I mean, I am under like the whole duration. I'm just trying to rebuild my concepts of Web3 throughout the whole like.
That was a lot of info dump though. My
I'm
bad,
telling
guys.
you,
Yeah.
life before this, life after this, literally has to be there.
No, I think this would just change me, like how I look at all of these buzzwords, at least. Like
And all of my
arbitrage,
friends who have made so much money
protocol,
out of it.
Yeah.
Yeah, protocol, arbitrage, or even NFTs I would like now see differently. Smart contracts are different for me now.
Yeah,
So,
and like for example, there are a few NFTs where there's this NFT called Pudgy Penguins.
okay.
So what they do is they have like people. There are 10,000 NFTs or something, whatever. The company behind these NFTs, they made toys.
Okay.
Okay, and whoever holds these NFTs get a portion of the revenue
Oh, okay.
for all the
It's a
toys.
revenue share, no? It's like a normal.
What are they gaining out of it even?
Again, like now it's very similar to shares and dividends.
Investment they got, no? Initial
Yeah.
investment.
अच्छा because NFT के लिए पैसा दिया होगा किसी ने?
Yeah.
अच्छा.
So now they're getting a return
So
on
you
their
believed in their
Makes sense.
Yeah.
plushies. So you believe that the penguin they'll be selling
Those are
or
some
whatever
cute
toys they'll be
penguins.
selling, it will be worth something.
Nice. So basically, you've never broken fraud before.
Not on mainnet. Thank God. Please don't.
We'll not jinx it.
Scares me.
We'll not jinx
No
it.
good.
No jinxing.
Yeah, our protocol has like millions of dollars, bro.
Correct.
And another thing about Web3 is that all code is open source. Everything. Let's say I make like the protocol I work for. It's a DeFi protocol.
Okay.
the code is open source. You can go and look at the code. Anybody can look at the code. Because in blockchain, you have this thing called trust but verify.
Correct.
You should be able to see what exactly happens when you do the transaction. Let's say if you swap Ethereum for USDC, you should be able to see exactly what happens. Even if you don't understand what that code is, there should be people around who can have a social consensus. Like for example, if there's a malicious code or something, people on Twitter, if you're in the blockchain circle, you'll immediately get to know.
Correct.
Like
That makes sense.
Correct.
there's a hack. You don't interact with it.
Damn. This was so fun. I loved the way we built BPC in general.
BB is a good network.
Yeah.
To the moon.
To the moon.
Literally to the moon.
That's how we close it.
Yeah.
Thanks a lot. Now we'll close this off.
Thanks for inviting me, guys.
Follow the leader.
Hey, good one, guys.
Yeah.
Really good, really
Actually
good
good one, bro.
So fun. And that wraps up season 1 of our Breaking Prod podcast. Thank you so much for tuning in all the way to our season finale. This season, we brought you 10 episodes packed with raw, unfiltered conversations on those niche topics we usually don't hear enough about in tech. From side hustles and remote work adventures to the courage of switching jobs and even dreaming of an early retirement in your 20s, we've covered it all, hoping to bring you insights and inspiration for your own journey. It's been an incredible ride, especially during our live premieres where we've connected, shared laughs and made some lasting friendships. If you've missed any of these episodes, the whole season is available on our channel, perfect for binge watching or sharing with your tech enthusiast friends. Don't forget to like, subscribe and share your favorite moments with us by tagging us on Twitter, LinkedIn or Instagram with the hashtag BreakingProd. We're so grateful to have you with us and can't wait to see what's next. Until next time.